This series focuses on data structures and algorithms content, and particularly in this recording I will talk the first part 1 of selection sort algorithm subseries. The second and third parts will present coding and analysis of this algorithm. Suppose we have these elements in an array with the element values equals to 18, 6, 3, 12, 9, 36, 21 and 15, and suppose we want to arrange these elements in ascending order or increasing order of their values by using the selection sort algorithm. This algorithm operates by first putting all the elements under consideration. In this case, a green rectangle encloses the elements currently being considered. To clarify this, that means the term elements under consideration, the selection sort algorithm runs in several passes, and in each pass there is a number of elements under consideration for processing by the algorithm. That is what we mean by elements under consideration. From among the considered elements, the selection sort algorithm finds the smallest element or the minimum value element, which is 3 in this case. This smallest element is then swapped with the first element. Having completed the swapping, we have the smallest element in the first position, the value 3 in the first position. Since we plan to sort the values in ascending order, which will eventually have the smallest element placed in the first position, we do not want our code to touch this element anymore until the end of the algorithm's execution. So we lock the first element, value 3. Now the elements under consideration enclosed by green colored rectangle does not include this value 3. This is the end of the first pass of the selection sort algorithm. In the second pass, again the algorithm finds the smallest value. Here the smallest element is itself the second element. Therefore we decide not to swap, and there is no point swapping the elements with itself. So we decide to lock this element. Now we get into the third pass. In the third pass, again we find the smallest element in to be the value with value equals to 9, and we swap this smallest element with the third element, which is the first element in the green rectangle. Having swapped, we have the smallest element in the beginning, so we lock this element. Now again we find the smallest element in the green rectangle, which happens to be the first element or fourth element in the array, and we decide no swapping, and we directly lock this value, this element. And again we follow the process. We find the smallest element in the green rectangle, which is 15. We decide to swap with the first element in green rectangle, 18. Having swapped, and after that we do lock 15, and following the same process we find the smallest element, which is again 18, and we decide to swap with 36, sixth element. Having swapped, we have 18 placed in the position where the 36 was there before, and we decide to lock 18, and again we follow the same process. We find the smallest element in the green rectangle, which is 21, and it is the first element, so we decide no swapping, direct locking. And finally we have only one element in the green rectangle, so we don't have anything to swap with, so we lock this element. Now at this point we have all the elements placed in the increasing order, so it is in the swapped state. So 3, 6, 9, 12, 15, 18, 21, 36. Now we have the array in the sorted form. If you want to sort in descending order, then you will have to find the largest element and swap with the first element in the first pass and follow the same process in the other passes. That will give you the array sorted in the reverse order, in the descending order. Or you can find the smallest element and swap with the last element and follow the same process. So this is all I have to talk in this video. In the next recording I will do coding for a selection sort algorithm. Thank you for watching this video.